Hello, my friends. Today we're going to have another amazing DevNation Tech Talk. I'm Edson Yanaga. I'll be your host today, and we have a special guest. Bartosz is streaming directly from Zurich, Switzerland, and he's going to be talking about Kubernetes, Istio, Telepresence, and maybe testing your stuff in production. So without any further delay, Bartosz, the stage is yours.
All right. Thank you, Edson. Hello, everyone. I'll just start sharing my screen, so please let me know if you can see it, Edson. Gonna take a second, I guess.
All good.
All right, great. So, yeah, today I have maybe a bit of a controversial topic in a way. I'm gonna show you how to use Telepresence with Istio on Kubernetes so that you can develop and test your code directly in your cluster, but maybe even on production. And when I say and discuss with people that we should develop on production, they often react like I'm crazy. So I hope that during this presentation, when I show you some tools that can make this vision reality, you're not gonna believe that it's not that crazy, but actually it's possible and very appealing. But let's start with the basics. When we say about development or the development process, we can actually talk about cycles or loops. So the one which we probably face the most in our daily life is the inner loop. And this is where we transfer our ideas to code. And then we run it somewhere, we validate if it works, and if it doesn't, then we most likely debug. And in the world of monoliths, so not that long ago, and they still exist, these activities were fairly easy. It was very easy to reason about our apps. It was easy to debug. It was actually very easy to spin up the whole stack and run it locally. But as we move to distributed world, we assumed this should work the same, but the reality proved otherwise. And I mean, when we talk about small amount of containers, we do have tools like Minishift or code-ready containers, or previously Minishift. So it's actually very tempting to spin up the cluster locally with a bunch of those containers. And if we are starting our new project, it might be actually working well. But in the longer term, the reality is getting more and more complicated. We are not talking about 2 or 3 or 4 containers, but we actually start talking about hundreds of them. And even if we use stacks like Golang or Quarkus with GraalVM, so with very low resource consumption and memory footprint, but if we have 100 containers, so 100 services, and each of them use, let's say, 30 megs or more of RAM, it's getting very, very heavy for our laptops, for our local machines. So it's not really rare, at least in my case, that my CPU reaches easily 80, 90 Celsius, even if I don't have Slack running in the background. So we have to find a better way. And even then, when we go out of the inner loop, we build our changes externally, we run integration tests, we deploy it somewhere, and we ship it. We still have to find a way to answer the very fundamental question. Will this work on production? Are we certain that the changes we just introduced will not break and not annoy our users? And we obviously have certain strategies which we came up with over the years of creating software. And probably one of the most popular ones is, yes, I jumped a few slides too much. Okay. So one of the most popular ones would be a staging environment. But it comes with trade-offs. It comes with its own challenges. It's actually quite hard to keep it in sync with prod. because it might be not even possible to replicate the same volume of data, not to say replicate the same volume of traffic. It's also costful because we have to maintain it. So we have to have not only the infrastructure, which replicates the prod, but also people who will take care of it. But on top of it, we are still not certain if our changes will not break the actual user experience in production. And if we consider all these development loops, so the inner loop where we code and validate locally, and the outer loop where we go out with our changes to a CI/CD cycle, we still can feel that it's actually very, very time consuming. The feedback loop is still long, and we as developers, we want to see our results fast. We want to be productive. So what if I told you that actually there are tools which let you test and even develop on the cluster, production cluster ultimately, with confidence? And there is a bunch of them, but the one which I found very interesting is Telepresence. Telepresence is a tool which is right now in a sandbox of CNCF, so it has quite a bit of traction. It's a very vibrant community, and it actually works in a very smart way. So in this diagram, what I'm trying to explain is that when you work on the service A and you run Telepresence, what you actually are doing is you interact with the real cluster, so you don't have to spin up all these other containers and make your laptop sweat. The only service which is running is the one which you are working on, and this runs locally. But thanks to Telepresence, what's actually happening is that it feels like it runs in the actual cluster. So Telepresence under the hood will swap the deployment of the service A and throw in its own proxy. And then with some DNS and IP table magic, which I won't explain or even dare to explain right now, it will reroute the traffic to your machine, but also will let you communicate back to the other services in the cluster. So this will makes your experience like you would be actually developing directly in the cluster. However, Telepresence on its own comes with a few shortcomings. And one is that it's actually somewhat all or nothing approach, meaning that if you replace service A, all the traffic would go to your local machine. And that means that if you do it on production, but even in the staging environment where other people are trying to verify their own changes, it will all blow up eventually. It will not work the way how others would expect it to work. So we need something more on top of Telepresence to actually bring this safetiness of developing in the actual cluster. And this is how Istio Workspace project was born. And one of the components is called Ike, which is our CLI tool, and that would be part of our demo later on. But before we dive into it, let me just explain where we are coming from. So when we started the project, we actually came from different product experiences, and we learned the hard way that development on the cloud, development with distributed systems is coming with a lot of challenges, and that the productivity we used to know from the previous life, so monolith system, is something which has to be improved dramatically. So our first goal was to have an easy way to validate our changes, but without messing up with the others, so meaning the services or the actual users which are using our app. The second goal, what we wanted to have, is that the interaction with the other services happens actually in the cluster, because there is limited capacity on our local machines that we can run the ever-growing, ever-evolving microservices architecture. I mean, to put it in a simple way, there is no way you can run Netflix on your machine, for example. And the third goal is that knowing all the local tools we love and we are used to and we figure out cool tricks with, we didn't want to have any other tool introduced so that we have to develop stuff. We want to use our beloved IDEs, let it be Eclipse or IntelliJ, VS Code, whatever, but still have this local experience of a fast development cycle, but with a way of interacting with the cluster in some sort of a native feeling. So the Istio Workspace project is actually coming in two flavors. One is the Kubernetes operator, which coordinates cluster setup, and then there is a controller underneath which will keep track of the development activities and will do some additional orchestration. And the CLI tool called Ike, which we will use to have this local development experience. Obviously, this works on Openshift, therefore works on Kubernetes, vanilla Kubernetes, and we make sure that it actually works on both. And one of our strategies, which will be part of the demo, is based on Telepresence. But as I said, Telepresence is a powerful tool giving you this local experience, but letting you interacting with the cluster. We do provide several other strategies. So the Telepresence for us is a bit of a building block. We do contribute actively to Telepresence, and we also make sure that it works on Openshift. We send a bunch of patches to make it happen. But with the limitation of the Telepresence on its own, where we swap the whole service and the whole traffic goes through our laptop, we actually need something more. We need something which will let us orchestrate the traffic, so only us or people involved in our, let's say, feature development will go through the new version of the service, whereas all the others will not even notice a glitch. They will still use the service which is proven to work somehow through the testing or other ways, and it works seamlessly on production. And for this purpose, we use Istio. And I don't really have time in this slot to discuss Istio in great detail, but if you go over the YouTube channel of DevNation of Red Hat developers, you will see plethora of interesting talks about it. What I only want to say is that Istio, giving all the benefits of abstracting, let's say, the infrastructure aspect, let it be circuit breakers, the routing, all the things which we shouldn't really bother about in our service code, gives us, the users of Telepresence in this context, one feature which is crucial. And this feature is traffic splitting. This gives us a way of deciding who can hit this service under development, but all the other users or the other requests should go to something which is proven, stable, and working. So for the purposes of the demo, what we're gonna see is a tiny little, let's call it microservice application, which consists of 3 services. If you are familiar with Istio, that's somewhat similar to the Istio book reference application. So we have 3 services. There is a customer which calls for the preferences, and the preference finds some recommendation. What we're gonna see live is 2 things. One, that's gonna be the local development through Telepresence. So we're gonna have a smooth way of interacting with the actual cluster, but running only one service, which we're gonna change in our machine, a local machine, in this case my laptop. But we're also gonna have a GitHub pull request, which we're gonna build and test as well. That's not gonna be based on Telepresence, because as soon as I will finish my activity, I will kill Telepresence client, the deployment will disappear. So we do provide this other strategy, which I mentioned before, which let you keep it persistent. And for the CI/CD part, so for the PR part of the demo, I'm gonna use Tekton, which is a foundation of Openshift pipelines. So with that said, I'm gonna switch to the demo part. Okay, so as I showed you before on the slide, we're gonna have a little app consisting of 3 services. What you are looking at right now is Kali. Kali is a visualization or a console which visualizes the whole traffic, in this given example, in your service mesh, and it's right now integral part of Istio, and it's a contribution from Red Hat to the Istio ecosystem. So this is our application, and I do have a little watch here. So this, what it does underneath is it calls the customer service, our entry point, and then there is an interaction with the preference and recommendation. And as a part of our demo, I'm gonna introduce some local changes, but then also the pull request. So there will be something shown up here. Right now there is nothing because we don't have anything else in the cluster yet, but this will change on the way. So let's say, as a developer, I want to introduce some new change in my preference service. So in order to do that, what I'm gonna invoke is our Ike tool. And when I say Ike develop, which is the entry point, entry command, and I say I want to develop the deployment on the deployment called preference v1, and then this is my workspace, and I set some other features, and the whole app is based on Quarkus. I run it on the dev with the dev mode. So this is actually running right now here. You see that the route is reachable, but it's not any different from the production, therefore you don't see any changes. If we have a look before we dive into code, what happened in the workspace demo namespace in the cluster is that we have 2 extra things. We have the Istio workspace controller, which has been installed for us. But then you also notice that we do have 2 instances of the preference service. This one, which is the safe one, the one which will be available for production users, but also the new one which we just created using Ike and Telepresence underneath. If we have a look underneath of it, you see that it's actually the Telepresence proxy. What we can also look is what's happening from the Istio workspace perspective. What we have is so-called session object, and you see I have a feature which I call feature Y, and here I have the whole definition of what's going on. I actually just say I'm using the telepresence strategy on the deployment version, preference version 1. Then there are some special parameters which will let me decide if I'm allowed to go to this given instance of the service or not. And then we have some internal structure of, let's say, events which happened on the way. So you can see that we actually modify a few things in Istio objects themselves or custom resources. We do change virtual services and destination rules, where we essentially just say, for example, we want to have all the traffic coming from this subdomain to go to our new service. So if we look at now at the code, we are in the preference service, and I will just do this important change for the new feature. I'll change the log to say it's local. What's happening underneath is that in our setup, I have my local instance running in here in the Quarkus dev mode. It picked up the changes, do the hot replace, and you see that the customer local route actually changed, but the production still stays the same. And obviously, only this given service has been changed. The other one, the recommendation service, as you see, the counters are kind of aligned. It's still hitting the service from production. And if we check if Kali changed something, you actually see that there is a feature v1 deployment created. And this is what Telepresence deployed with Istio workspace involved, but we have 2 different flows. All right. If we switch back to K9S, which I highly recommend you to see, we can quickly verify the changes in the virtual services. You can see that we have a customer virtual service, but we also do have the feature Y customer virtual service, because that's our entry point to the whole network service graph, right? If we have a look at the destination rules, you see that at least in the preference destination rule, there is not only the subset for the production route, but there is also the new one created. Okay, so let's assume I'm happy with my change. So what I will do right now is I will stop it. And I'm about to create the pull request. For that, I will quickly jump to editor and just make it different. And we can just commit the changes. But maybe first we're gonna create the new branch. I call it feature X because that's what's gonna go to the pull request. And then I can say fit shows new logging. Very important feature to have. Then I just push upstream and push to origin to the new branch. And I will switch to the demo repo, where you can see I have a way of creating a pull request here. I just give some meaningful description, and I will create the pull request. Now very soon our Tekton pipeline should kick in. As you see, it just started. It's a PR build, and it's a bit of a complicated beast in a sense, because what we are dealing with in our demo is a setup of a monorepo. So all these three services are actually living on its own. There's no single master POM which combines them together. You can just switch between those three services as a separated project. So our pipeline actually just checks which of the services has been changed and kicks the build which is relevant. I mean, these are marked as failures because I don't think there's a way of showing skipped right now. I'm not sure. But this is not a failure in the sense that something which is wrong and needs to be immediately taken care of. So this will take a second or two, but once this is done, what we're gonna see here is a comment which will let anyone who is involved in reviewing the pull request to actually see it. So if we pick on the Kiali, I guess it's still showing the old things because we have a last 5 minutes from here. If there are any questions, Edson, I'm happy to quickly answer because this will need to build an image, so we have at least a minute to discuss anything which might.
All right. I'm not seeing any questions yet on the chat. Oh, by the way, if you have any questions, please fire them. Bartosz will be more than happy to answer them for you. But I have a question for you. Right now, Telepresence seems to be amazing because I have the opportunity to be developing using the production services. Can you think about any downside of using this, like using this approach that Telepresence provides for us?
Well, so, I mean, it obviously brings a certain level of complexity, but maybe not due to the telepresence itself, but due to the approach, because as soon as you get into the statefulness, you need to find a way to have this safe way of manipulating stuff, right? You can't really have this new service which change the same data which is exposed to the users. But that's something which you cannot universally address. It really boils down to the particular architecture, particular project. There are certain strategies which I would be thrilled to discuss in another installment, but this is the serious consideration you should take into when you look at telepresence, right? It just enables you to do this thing, but there are certain additional aspects you have to consider. And obviously, since it's doing some IP tables, DNS reconfiguration, you need to have certain security enhancements in place because it won't work in the secured environment out of the box. I am not sure why I don't have a comment yet, but I believe that at least on the demo, you see that I have a preference PR shown. So this is this new image which we deployed, and it's run in the cluster right now, but you still see that the traffic going into the regular user, traffic which regular user encounters is untouched. All right, there is a comment right now, so this is nice convenience. My bot says, okay, the changes are ready to be reviewed. So once the build is done, you will get this feedback. And just to mention, our integration is very lightweight. We do have an integration with GitHub Actions as well. There is nothing which is, custom written plugin for any sort. You just use the same CLI as you used for your local development. This is just a different command involved. All right. But what if, let's say, my changes, which looks good in the demo here, actually brought some regression into the recommendations service? What we can do is we can join the PR and create the local version of the recommendation service and do some changes on the fly. So what I'm doing here is I'm again invoking develop. This time I'm targeting the recommendation deployment, and I'm saying I want to join already existing feature X session. Feature X is the one which already started the pull request. So in a minute or two, or maybe quicker, actually very quick, because Quarkus is a very quick framework, very quick turnaround. What we can see is that I'm actually hitting my local machine right now. So with that, I do have my IDE, so I can actually start debugging. If there is some problem, I can just attach the debugger, very easy way, no remote port forwarding from Kubernetes, it's just a local process. And you see that I have a breakpoint hit immediately. And in here, the counter actually stopped. And I can do some changes, let's say for really sake of the demo and respecting the time of everyone, I'll just set the counter to 1 and rerun. And you will see that it actually set back to the original value, right? My breakpoint is still hitting it, so I will just disable it right now. And the counter should be increasing. Okay, and once I'm done with these changes, I can actually commit this to my repository and get this whole PR fixed together. So I switched immediately from the local copy of recommendation back to the route which is from the PR. Everything is nicely fixed. What I can do right now, I won't merge it. Let's say I'll just close this pull request. And our Tekton integration will run the cleanup jobs right now, but you will see immediately in here that this will be gone. The cleanup will happen, and all these services will be bring back to the real original state. And the beauty of this whole situation is that I messed around quite a bit. I mean, leaving aside that this is just changing some strings, but that's just a demo simplification. But this guy, the route on production, was never changed. And with that, that's the end of my demo. So I'm happy to take some questions, but before I do that, I'll just share with you where you can find the project. So it's under Maestra.org, and the project is called Istio Workspace. This is where you can find the binaries you can use right away. We have, we believe, quite extensive docs. We do have some getting started guide. We do have some extra videos which you can watch to see some other interesting aspects. But this is the repository where everything happens. So feel free to give it a spin and let us know if you find it useful. All right, Hudson. Awesome. I guess we are. I'm all done right now, so I'm happy to answer questions.
Yes. I guess we have a question from Prabhat, and forgive me if I mispronounced your name, Prabhat. What else do we need to install in our cluster to be able to use Telepresence? Right.
So for Telepresence, the only thing you need is if you use Openshift, you need to add certain privileges. If you go to the telepresence.io, there is a section about Openshift which guides you exactly what kind of roles you need to add. Other than that, from the cluster perspective, Telepresence is just an image, just a pod which sits there. And in vanilla Kubernetes, you don't need anything. I mean, it's only in the secured environments where obviously you will most likely need to tweak something so that the tool will do its magic. And from the client, from the overhead, well, so the proxy itself is a very small thing, so there is not much overhead. And actually, I mean, the overhead from the local side is also close to something you can neglect because it's just tiny wrapper around however you run your service locally, right? So that's it. And that's the whole beauty, that you don't need to run all the other stuff you need to develop changes or features in your service. You just run this service and the rest can be served from the cluster directly.
And do you know anybody already using this Telepresence feature in their projects?
So I can't tell the exact information because I'm not the committer on Telepresence, nor I'm just a community member. But I do know that they have some customer customer success stories. So there are definitely companies, people using that. You can actually see from the huge amount of contributors and traffic on the issue trackers that it's widely used. I mean, maybe widely is a too big word, but it's a popular project. Otherwise, I guess it wouldn't pick up the interest of CNC.
Hey, awesome. Well, we're already on top of the hour. So I'd like to thank Bartosz. I'd like to thank you that is watching the session. I hope you
Thank you so much.
You are excited, just as I am, about this amazing content and this amazing session. So I hope to see you next week with the next DevNation Tech Talk.
Thank you so much. Have a good day.
You too.